Welcome to Unit Circle Survival Guide. Today we're going to focus on knowing your unit circle. So we will be able to fill out an entire unit circle, naming the angles in both degrees and radians, as well as the ordered pairs. This will give you a really good foundation to build all of your trig knowledge on. And note that you should be able to learn the unit circle without a lot of memorization. This video is going to focus solely on how you can complete the unit circle, but I'll post some links in the video description that dig into more detail about these things. All right, so here is a blank unit circle, and let's go ahead and fill it out. So we'll start by naming the angles in degrees, and remember these are the angles formed by the initial side here, and then, for example, a terminal side, so this angle of rotation. All right, so let's start by filling in the degrees. And I like to do this in 2 rounds. First, focusing on the angles that fall on the axes and those that fall on the angles halfway between, so counting by 45s to label these. And then we'll go back and count by 30s and fill in any that are still missing. All right, so let's count by 45s first. 0, 45, 90, 135, so just adding 45 to the previous, 180, 225, 270, 315, and of course 360. Now we'll fill in the missing blanks, counting by 30s. So we have 0, 30, 60. Notice 90 is already filled in. It's an angle that lands with its terminal side on an axis, on the y-axis. Keep going, 120, 150, we have 180, 210, 240, we have 270, 300, 330, and we have 360. So we've got it all of the degrees labeled. Now on to radians. Follow the same sort of pattern, so we'll be labeling first the axes and those in between. So what were the 45 angles? And we're going to do this counting by pi over 4. Because we should know that half a rotation of the circle is pi radians. And notice that we have the first half of the circle, the top half, divided into 1, 2, 3, 4 pieces. So count by 1 pi over 4. Okay, so starting at 0 radians, we have 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, and 4 pi over 4. And keep going with that same mindset, but now we'll be counting over 1. So we have 5 pi over 4, 6 pi over 4, which reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4, which of course is 2 pi. Now we'll break the pi, that top half of the circle, into 6 equal pieces so we can count by 1 pi over 6. So notice here we have the remaining to be labeled, as well as we already have pi over 2. Okay, so you see those 6 equal pieces there. 1, 2, 3, 4, 5, 6. So you're breaking pi into 6 equal pieces. Okay, so let's count. We have 1 pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, we've already labeled as pi over 2, 4 pi over 6 reduces to 2 pi over 3, 5 pi over 6, and 6 pi over 6, which is, of course, pi. So let's keep going. 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, which is 3 pi over 2 when we reduce. 10 pi over 6 reduces to 5 pi over 3. And 11 pi over 6. And of course 12 pi over 6 is 2 pi. So now we're ready to label our ordered pairs. Let's start first by labeling the quadrantals, or the points that are on the angles that are on axes. So we know the circle is centered at the origin at 0, 0, and we know the radius of the unit circle is 1. So if we move 1 unit to the right to get to our first point, we have 1, 0. Okay, so same idea. If we move to the point that's on pi over 2, that's 0, 1. You have to move left 1 unit for the point on pi, and down 1 for the one on 3 pi over 2. So to label the remaining ordered pairs, we need to rely on our knowledge of our special right triangles, our 30, 60, 90, 45, 45, 90, and I like to call it the 60, 30, 90 triangles. So if you are not familiar with those, I'll post some links to the videos that review that in detail. But for now, we'll assume that you know those special right triangles. So let's look briefly. Let's sketch in our first right triangle. So this is a 30, 60, 90 triangle. And recall that, of course, the hypotenuse was 1. So we found the short leg to be 1/2 and the long leg to be square root 3 over 2. So to get to our point on our 30-degree angle's terminal side, we know we have to go right, square root of 3 over 2, and up 1/2. Now, a great thing here is we can go ahead and fill in 3 other ordered pairs using these same values and just adjusting to where they are negative when appropriate. Okay, we have this angle, and this angle. So you could draw in the full triangle. I'm just highlighting the reference angle, or the angle that it takes to get back to the x-axis. All of those have the exact same triangle legs. The horizontal leg is root 3 over 2 in length, and the vertical leg is 1/2 in length. So to get to the point on 150 degrees, or 5 pi over 6, you use the same triangle. You just go to the left root 3 over 2. So we label that x-coordinate negative root 3 over 2. And of course, you still went up the short leg 1/2. Okay, so similarly for the angle in the third quadrant, 7 pi over 6, or 210, same triangle leg lengths. We just went to the left and down to get to this point. So we'll label that negative root 3 over 2 and negative 1/2. And finally, at 330, or 11 pi over 6, we went in the positive direction along the long leg and in the negative direction on the short leg to get to this ordered pair. All right, so next round of 4 come from our 45, 45, 90 triangle. So that's our triangle right here. Okay, and that'll be these reference angles. So using our knowledge of the 45, 45, 90 triangle, we can find that the 2 legs are equal and they both are root 2 over 2. So to get to the point on 45 degrees, or pi over 4, you simply go right, square root of 2 over 2, and up, square root of 2 over 2. And that's equal in length to about 0.7 as a decimal. Okay, so now that we've found the coordinates for our pi over 4 angle, we have found the coordinates for all the reference angles that are pi over 4, so for all those angles, and we just need to adjust the signs. So for our second quadrant angle, we went in the negative direction horizontally, but those side lengths of the triangle stay the same. So our x-coordinate is negative. When we move to our third quadrant angle, the 5 pi over 4, or 225, we have both are negative because we went left and down. And then in the fourth quadrant, 315, or 7 pi over 4, must be positive root 2 over 2 for the x, and we went down to get to that point right there. So negative root 2 over 2. All right, finally we'll be filling in the coordinates for our pi over 3, or 60-degree reference angle. And that comes from a 30, 60, 90 triangle that's just been flipped and reoriented. So the values are the same, but they're just reversed because now our short leg is horizontal and our longer leg is vertical. So we'll be able to find those ordered pairs for all of the angles that have a reference angle of 60 or pi over 3. So again, we know if our hypotenuse is 1, our short leg must be 1/2, and our long leg must be root 3 over 2. So we go right 1/2 and up root 3 over 2. So our x-coordinate must be 1/2, and our y is root 3 over 2. All right, so we can fill in the other coordinates, and all we have to do is adjust. So a negative x for the angle in the second quadrant, positive y. For our angle in the third quadrant, so 4 pi over 3 or 240, both are negative. And in the fourth quadrant, we have positive x, negative y. Hopefully this helps you better understand some of the patterns for filling in a unit circle. Knowing this is such a big help as you start trig, so just practice. You'll get quicker and quicker as you do a little bit more practice, and you may find that a slightly different ordering of labeling may work better for you, so use that. Remember, if you need help with any of the topics I mentioned, digging a little deeper into special right triangles, that sort of thing, or even just labeling in degrees or in radians, you can check out those links in the video description. Otherwise, thanks so much for watching.